Hi, in this video, I would like to talk about how we use linear approximations to help us to approximate some number. Okay. For example, if I want to approximate square root of 4.2, okay, how do we actually do this? Now, of course, one thing about this is we know that the square root of 4.2, this number is in between the square root of 4 and square root of 9. Okay. Again, why I use square root of 4 and square root of 9 to compare? Because we know that square root of 4 is 2 and square root of 9 is 3. So then in this case, I know that square root of 4.2 is equal to 2 point something, right? Something like this. But what is this something then? Okay, so in this case, we would like to see how we actually use linear approximation to help us to do this. Okay, so before we work on the problem, then let's see how we actually handle this type of approximations then. Okay, now first of all, we need to have f is differentiable at a and x is close to a. Okay, now to our example, what is a, what is x right here? You could actually consider that a is 4. Okay, again, use the example that we have here. We want to approximate square root of 4.2. Okay, a is equal to 4, and then x is the number that we would like to evaluate. That's mean the input that we are using. Okay, and of course, in this case, what is the f functions? Okay, the f function, maybe we could consider that the f function is square root of x then. Okay, because we would like to work with square root of 4.2. Okay, and then the tangent line L of x is close to f of x. Okay, so this L of x basically is the tangent line at x equal to 4. Thus, we would use the tangent line at a f of a. In this case, you could consider that this one right here, it will be 4 and f of 4 then. As an approximation to the curve y equal to f of x when x is near a. Okay. Then you will see that again, if this is the maybe let us draw the functions. Okay, so again, this one right here, it will be f of x equal to square root of x. Okay, and then the 4.2 is here. Of course, in this case right here, this output right here, it will be 4.2 and square root of 4.2. This is what we're looking for. Okay. And then now, if this is the 4 right here, this is the this point right here, it will be 4, f of 4, which is 2 then. Okay. Then this is the tangent line that we have at x equal to 4. Okay. And then we call this tangent line L of x. Okay, this is what we have here. Okay. And now you will see that just by looking at the graph, okay, the diagram that we have, this point right here is a point on the curve, which is L of 4.2. Okay. Do you see that L of 4.2 is really close to square root of 4.2, isn't it? Okay, so this is kind of like the idea using the linear approximations. Okay. Okay, anyway, let us look at the detail now. Of course, to find the tangent line, we need the slope of the tangent, which is f prime of x, and the point a, f of a. And then we are going to use the point slope form, okay, is y minus, in this case, you could consider that is y minus y sub 1 equal to m x minus x sub 1. Okay. Then we have y minus f of a equal to f prime of a times x minus a. Then if I want to solve for y, then I have y equal to f of a plus f prime of a x minus a. Okay, so we know how to do, that's mean how to find the tangent line. Okay? And then in this case, okay, and now you will see that what is f of x? In this case, you could consider that this one will be square root of 4.2, which is equal to, okay, the number that we have, the value that we have is on the L functions then, which is L of 4.2. The right side of the approximation is called the linear approximations or tangent line approximations, or sometimes we call it linearizations then of f of a, and it is often expressed as a functions with the notation L of x. Okay. So in this case, L of x is f of a plus f prime of a times x minus a, which is the tangent line. Okay. And now you will see that f of x is approximately equal to L of x, as x is in the a. Okay. Sometimes we would like to replace x minus a with delta x. Okay. So then in this case right here, this will be the delta x that we have here in the last equations. So the statement become f of x is approximately equal to f of a plus f prime of a times delta x. Okay. Okay, so now then let's see how we actually calculate, work it out, the problem, and then using a linear approximations, okay, L of x, to estimate the square root of 4.2. Okay, so then I'm going to show you calculate the step and procedure. Okay, now first step, I'm looking at the numbers, and then the number is a square root of 4.2. Then the first step is I would like to create the function then. F of x. Okay. So in this case, of course, I think that I would like to use a square root. Okay, f of x equal to square root of x. Okay. Then now the second step. So step number 2 is actually we would like to choose a number that is close to the input 4.2, but it is easily to evaluate. Of course, in this case, without using calculator, okay? With the functions f of x equal to square root of x in this case then. Then now in this case right here, we have two choices. As we mentioned that we could use 4 or we could use 9. Okay. But in this case, I will choose 4 instead of 9 because 4 is closer to 4.2 than 9. Okay, so then in this case, we select A equal to 4. Okay. Okay. Then again, if I look at the graph, this is exactly what we would like to do. Okay. Let me redraw the picture or diagrams that we have. This is the value that we are looking for. 2 squared of 4.2. And now I'm select the 4 right here. Okay. Then this is the tangent line that we are looking for. Okay, and then eventually we will call this tangent line L of x. Okay, at x equal to 4. Okay. Okay, then now step 3, we would like to find the tangent line at x equal to 4. Okay. And now we know the function is f of x equal to square root of x n, which is x to the 1/2. And then we would like to evaluate at x equal to 4. Then f prime of x is 1/2 x to the negative 1/2, which is 1 over 2 times square root of x then. And the slope of the tangent is equal to f prime of 4, which is equal to 1 over 2 times square root of 4. And then we have the point, which is 4 f of 4. Okay. And of course, in this case, f of 4 is the square root of 4, which is 2. Okay. So then in this case, the point that we have will be 2, 4, 2 then. Okay. And now I'm using the Poincare form, so I have y minus 2 equal to 1/4 x minus 4. So this is the tangent line that we have. Okay. Okay. And then now, step 4. I'm going to rename y equal to L of x. Okay. So we will have L of x is equal to 1/4 x plus 1. Okay. Then step 5, I would like to find the approximation now. That means I have f of 4.2 which is equal to square root of 4.2, which is approximately equal to L of 4.2. Okay. And then what is L? Function L is 1/4 times 4.2 plus 1. Okay. So then in this case, I have 1.05 plus 1. So it is equal to 2.05. Okay. So meaning in this case, square root of 4.2 is approximately equal to 2.05. Okay. So let's see how accurate, accurate, okay, this number is. What we could do is we could check the result using calculator then. Okay. So if you use your calculator to evaluate square root of 4.2, okay. So square root of 4.2, it is equal to 2.049390,153. Okay. And then you compare to our answer 2.05. Wow, you will see that they are really close, right? If I round the number square root of 4.2 to 2 decimal places, they are the same then. Okay, so this is kind of like the idea how we use linear approximation or linearizations, okay, to help us to estimate a number. Okay. Okay. Then now it is your turn. Now go ahead and try to see if you could work on number 2 on your own. Okay. Now again, try to see if you could follow the 6 steps, okay, to check your answer. Okay. Then now let's try to work it out about this problem. Okay. Then first, I have f of x equal to x to the power of 2/3. Okay. Second, I would like to choose A, right? So in this case, then let's see. I would like to approximate 8.06 raised to the power 2/3. Then one thing that I know is 8 raised to the power of 2/3 is 2 to the power 3. Okay. So which is equal to 4. Okay. So therefore, in this case, 8 should be a really good number then. Okay. Again, because when I work with the functions, 8 raised to the power 2/3 without calculator, it is, I could get a 4 way away. Okay. Then number 3, we would like to find the tangent line at x equal to 8 then. Then I have f of x equal to x to the power 2/3. Then f prime of x is 2/3x times x raised to the power 2/3 minus 1. It is 2/3 x to the negative 1/3, or 2/3 times cube root of x then. Okay, so f prime of 8 is 2/3 cube root of 8. And 2/3 times 2, so I have 1/3. So this will be the slope of the tangent. And then we are looking for the point now, right? Then I would like to evaluate f of 8. So it will be 8 raised to the power of 2/3. And then we find that this is equal to 4. And now we have y minus 4 equal to 1/3 the slope, and then x minus 8. Four times 3 is 12. 12 minus 8 is 4. So I have y equal to x/3 plus 4/3. Okay. Then now, step 4, I'm going to rename this to be L of x equal to x/3 plus 4/3. And then now, I would like to estimate. So f of 8.06 equal to 8.06 raised to the power of 2/3. Okay, this is the number that we would like to evaluate, which is approximately equal to L of 8.06. Okay. It is equal to 8.06/3 plus 4/3. Oh, wow. My bad. It should be 6 right here, right? 8.06. Okay. Okay. It will be 12.06 divided by 3. So the answer that I have, it will be 4.02. Okay. Then 6 is, we are going to check. Okay. And so the number that I get it from a calculator is 4.01997583. Okay. So meaning my answer 4.02 is really, really good approximation then.